Here we have another equation of a conic section, and we need to try and figure out kind of what kind of shape it is and how to graph it, and then if we're successful there, trying to find things like eccentricity and focal position and position of a directrix or directrice. So in previous videos we were looking at a parabola, which is when either the x or the y was squared. But now we have them both squared, and so this is going to be something other than a parabola. Now to kind of do a little Desmos sneak peek, if you type this equation into Desmos, which I've done right here, you can see what's going to end up evolving is an ellipse. Okay, not quite a circle, but a little elongated horizontally. We often say it's a bit eccentric as opposed to being perfectly round. And this is the ellipse. So let's kind of get into how we can figure out that this is an ellipse without relying solely on Desmos. Okay, so one of the tip-offs is if you have both variables being squared, okay, that pretty much rules out the parabola, that when both variables are squared and you see a difference in the coefficients, okay, that's an indication that you're dealing with an ellipse. Had these both been like 9x squared and 9y squared, you probably have seen on your assignment that led to a circle. And technically a circle is one type of an ellipse. So in general you're looking for both being squared, and especially if you see both numbers different here, then that's kind of a tip-off that you're looking at an ellipse. So then the question is, how do we go from this form, which we call the general form, which is not easy to graph by hand, into what we call standard form, which is a form that's easier for us to graph. Well, as was the case with parabolas, we end up having to complete the square. Except now we have to complete the square not for the x's, but we also have to complete the square for the y's. So we're going to have to kind of complete the square twice. So let's kind of walk through that process here. So again, we kind of group things together. Let's get our x terms together. I suggest you leave a little bit of space and then put your y terms together. The order doesn't really matter. If you want to do the y's first and the x's second, go right ahead. And I always think it's a good idea to take that constant, that 36, and bring it over to the other side. We can always bring it back later on if it suits us. But that would be the first step, is kind of get all the x terms together, get the y terms together, get the constant over to the other side. And then we're going to do a little bit of factoring. So if we factor out the 9, I'll go ahead and factor the 9 out from the x's, and I'll factor the 16 out from the y terms. This would be that would be the look if I did that. So now comes the completing the square step. And so again, we can kind of say, well, half of 4 is 2, and 2 times 2 is 4. So if I put a plus 4 here, that should make this thing factor into the same binomial. And we'll, in fact, now I guess would be a good time to check that. X squared minus 4x plus 4, kind of checking the factoring here, xx, and then 2 times 2 gets me 4, and then if I had minus 2x, that would make minus 4x. So this does factor the way I'd like it to, 9x minus 2 squared. And I'm going to do the same for the y's in just a moment, but before I forget, I have to be mindful of, okay, I've changed this problem. I've introduced a value on the left-hand side of the equal sign, so I've actually increased the value. So I need to do something over here to balance things out. Well, I have 9 times 4. I really have a value of 36 that's being introduced to this side of the problem. So I'm going to put a plus 36 over here. again, to get everything back in balance. And now I'll look at the y's. Half of 6 is 3. 3 squared is a 9. And let's again check the factoring on here. Some people are pretty confident in their abilities to complete the square, and so they don't really write down this check. And that's okay. If you kind of can just make that jump to the next step, more power to you. So let's see, 3 times 3 is 9, and then 3y and 3y add up to 6y. And so yeah, the factoring pattern checks out. And so I have y plus 3 squared, and then that's 16 in front. But again, we got to be mindful of balance. We have 16 times 9, which is the 90 and 54. That's 144 if you multiply those together. So I need to add a 144 over here to again keep things in balance. And hopefully I keep all this on the screen here. So now I've got these squares have been completed, and then let's look at what's happened over here. I've got a negative 36 and a positive. Well, those cancel out, and so really what I have over here is 144. So that's kind of the completing the square phase, and now we have to just kind of do one more step, and you'll find that the standard form for both ellipses and hyperbolas, which we'll look at in a future video, is we'd like this to be a 1 right over here. So in order to get 1, we're going to divide by 144 into all terms. Okay, so whatever this number is here, we're going to divide by it, okay, to kind of force this to be a 1. So that's kind of the goal here. You'll find that this form, this makes what we call standard form, ends up being a really nice form for graphing. Okay, well now let's look at what the result is. Now if we're lucky, these values here are going to reduce. And so you have 9 and 144, so hopefully I can divide 9 out of each one of these, and 9 out of 9 is 1. And then if I take 9 out of 144, that should work because 4 plus 4 plus 1 is 9. I seem to remember my division rule for 9. Let's see, 144 divided by 9, 16. Okay, so that makes a 16 right there. And then, so well, of course, that means that if I divide 16 out of each, I've got 1, and then this would end up being a 9. So it's almost like the 16 and the 9 kind of switched places. So what do we have here at the end? Okay, let me move this down a little bit. I realize I take up a little extra room there. So it would be x minus 2 quantity squared over 16 plus y plus 3 quantity squared over 9 equal to 1. So that is a standard form. I say a standard form because there's actually another way to do this, and some people really like this, some people don't care for it, is they write it this way, x minus 2 over 4 and the whole thing squared. And y plus 3 over 3 quantity squared. Hopefully you can see what I've done here is realizing that 16 is really a perfect square, and so if I had 4 squared, that would make 16, and then x minus 2 squared makes x minus 2. It's a little different way of writing it. And again, some people like this form. You can graph pretty easily with this form, and you could also graph pretty easily with this form. And so either one is fine for a standard form. So now let's actually talk about graphing this a little bit. So let me kind of slide the paper up some, and let's kind of create a little bit of space here. Maybe zoom back a bit so I can have a little more room on my graph. Okay, so let's And again, when you're first starting off, you're really probably not too sure how big or how small to make your axes. So I'll just make these fairly large. If I end up not needing all that room, that's okay. Live and learn. And just kind of move on. All right, so let's kind of see what we can do with this here. So so one is the idea that, okay, our conics are usually centered about the origin. And so if we think from a transformation standpoint, we could say, well, okay, we're moving our center right 2 and down 3. These are kind of inside transformations. So basically the center is going to be at 2, -3. So 2, -3, that'll be our center point. And whether you think about that as transformations of like kind of right 2 and down 3, or you just simply say, oh, okay, well, the center is going to be the opposite of each one, 2, -3, that works out just fine. And then what we have to figure out is kind of how far to kind of extend left and right and up and down. So again, one way to do this is some students like to say, okay, well, the root of 16 is 4, so I'm going to go right and left 4, right, 4, left 4, and then I'm going to go up and down 3. I simply take the roots of those numbers, and so I get my bounds here. Now, students that like to think about this from a transformation standpoint are thinking about taking this circle, which we've kind of recentered at 2, -3, and we've kind of done a horizontal dilation by factor 4. Remember, this inside transformation, dividing by 4 means we would actually dilate by a reciprocal factor. So dilate, take that diameter, if you will, and dilate it by a factor of 4. And then take the sort of the vertical diameter and let's dilate that by a factor of 3. And so you can think about them as in terms of dilation. So again, whichever you prefer. Again, some folks who use this form like to kind of say, okay, I see the center here, and I take the root of each of these to tell me how far left and right to go. Other students kind of think of it more from a, okay, I'm going to go right 2 and down 3, and then horizontally, I'm going to dilate by a factor of 4. Vertically, I'm going to dilate by a factor of 3. I mean, they all get you to the same place. Many roads to Rome, as we say. So you kind of now draw your ellipse. And again, ellipses are pretty round. They're really not pointy. You don't want to be making like a point here, like a kite shape. You want to try and keep this thing round if you can. So keep it pretty oval. And again, when you're first drawing them, you know, they won't really look even. They'll look a little lumpy or pointy. Just take your time. You students who've had a few art classes can always draw these things way better than those of us who can't. So, okay, so that would be your ellipse. And so let me kind of pull back that. And we can kind of check that against our Desmos graph, and let's see, I can get myself, where did I put it? Right in there. So my center's at 2, -3. That looks pretty good. And then it looks like I'm going left and right 4. I'm going up and down 3. So not bad if I do say so myself. So there would be the graph. Now what remains is to kind of find the focal points for this, the directrices, and also the eccentricity. But in order to learn that, you're going to have to watch the next video in which I talk a bit more about eccentricity. So hopefully this was pretty helpful on showing you how to get from the general form to the standard, and how to go from a standard form to making the graph. And on the next video, we'll bring in some eccentricity, and then we'll kind of come back to this problem and see if we can add in focal points, directrices, and eccentricity. So thanks for watching.